Hey, this is OXTF, and today we're looking at Ghost Wrangler, a reversing challenge from the HackTheBoo CTF recently put on by HackTheBox, beginner focused CTF. So some good beginner challenges. Let's take a look at this one. We've got, if we do an unzip -L on our download here for Rev Ghost Wrangler, it's just a single file in a directory. So we'll go ahead and unzip that, and it unzips. Let's see, we'll change into Rev _ Ghost Wrangler. And we'll start tmux here. So we've got the file. If we run it, it says, I've managed to trap the flag in this box. It's turned invisible. Can you figure out how to reveal them? So, you know, we could play with like putting arguments and things in, but not really gonna get very far. We could do strings. We always go to check the strings on the file. I'll just pipe it into list to take a look. And so here's the I've managed to trap the flag in the box. It's turned invisible bit. That's a somewhat interesting string just because it looks like it's kind of random and it's got the %s on it. But not much I can do with here. So I guess at this point, we're going to go ahead and open it in Ghidra. I've got Ghidra set up on my computer that I can just type Ghidra and it runs the starting script that they give you when you download it, but you can also download it and you could start it from there. We're going to open up a new project. Non-shared project, and we're going to put it in Rev Ghost Wrangler, and we're going to create a directory here called Ghidra. Select that, and we'll name it Ghost Wrangler. Looks good. Very creative, I know. And now we'll import the binary file. Oops, let's go back. Here's the ghost file right here. So it imports. And we don't really care about that. And then we need to drag it onto the code browser. And it'll take a second, but when it opens up, it's going to say it's not been analyzed. We're going to say yes. We're going to accept the defaults. This worked very quickly because it's a small binary. I always want to start here in the functions. We have a get flag function and a main. Those both seem interesting. Let's just check out main. And the main here basically calls get flag and the value comes back into here. We could probably rename this variable to be flag. And then it's going to print f on this thing with the flag argument. And I think it's actually misunderstanding these extra arguments here. Don't look like they actually get used. I don't see them anywhere in here. So printf takes the first string, and then for each % thing in there, it needs a thing to fill in. So in this case, it really only needs flag. So the reason we're not seeing the flag is because the flag prints out, and then this carriage return prints. \r is a carriage return, and it means move the cursor back to the front of the line. Typically, you'll see it like carriage return new line /n, and that's how it moves to the, in Windows, that's how it moves to the beginning of the next line. On Linux, %n or \n also moves at the beginning of the line. But when you move it back to the end of the line, beginning of the line here, and then start printing, this stuff all just prints right on top of where the flag was. So we're going to look at 4 ways to solve this problem today, because it's pretty simple. The first one is let's take a look at the get flag function. So it's got this buffer here, which is s. It names _s. We'll name it flag, because that looks like the flag. It's going to malloc or create a buffer for 29 bytes. That's 3241 bytes. It's then going to set that all to 0. And then it is going to loop. So we can name this I. For I is less than that, it's going to loop through it, and for each one, it's going to take it's going to set the flag plus I equal to this underscore. The underscore, it's going to go I bytes into underscore and XOR it with 13. So let's take a look at what underscore is. Like this here. It's just a buffer here with some data in it. One thing that's kind of neat to notice, if 5b47, I always go to Python when I need to figure out char ox5b. Is that square bracket g? You may remember strings ghost. Go up here a little bit. That actually looks a lot like this buffer right here. So that's kind of we could find that with strings, but just that's what that was. What I'm going to do here actually is select this whole buffer, and I'm going to right click. I'm going to do copy special, and I want Python byte string right there. And now I can come over here. I can open up a Python terminal, and I can say like encrypted flag is equal to, and just paste that in. And so this is a string. You can see the open and close quotes, but it's a byte string, and then it's got all the different values here. If we print ENC, it shows that same string we had up there. So now what are we going to do is we want to go over each character and XOR it by 13. So we're gonna do a little list comprehension here. So we're going to say E for E in ENC. What this is going to do is it's going to create a list where each element is, in this case, just the byte. It's going to go over each byte in ink, and it's going to print it. So we can do like that. And so 5B is actually 91. OX 5B is 91. So 91, 71, these are just the bytes. But we don't want just E. We want to do E XOR 13. And so now we have a new set of bytes, the XORed. We don't want that as an integer, though. We want to convert that back to a character, so we can pass it into char. And now we're getting very close. And we have a list of characters. If we do a empty string and then join and give it a list, it's going to take all of the items in the list and join them together using the empty string as the combiner. So we get the flag. You know, if we were to put a colon in there, we'd get them all separated, joined with colons, but we don't want it. So get the flag method number 1, just recreating, unencrypting the flag. Works pretty well. Let's go to item number 2. I'm going to use GDB to debug this. And I'm using a GDB plugin called Peta. You can look up on GitHub and figure out the install instructions and everything. There's a handful of different plugins that do nice things like this. GEF is another one, but I like Peta. It's what I've been using for years. So just, it's worth noting if your GDB looks different than my GDB, you might want to make sure you have Peta installed or something, some other kind of thing like that. So we can do GDB on Ghost like this, and we will do a break at main, and we will hit R to run. And now we've broke at the start of main. If we do disassemble main, and we could come back into Ghidra and get these addresses as well, but this one's simple enough that we can just look at it. We don't have to exactly know what's going on with all of these calls, but we can it'll definitely jump out to us that here's the call to get flag. So we're going to put a breakpoint right here. We'll copy this address. We'll do break and star to point to that address and put it there. And we'll hit C to continue. And now when that function returns, the return value is going to be in EAX. Looks like it's also in RDI and R8, but we can look up for sure at RAX, and there's our flag right there. We've managed to capture it. So method number 2 complete. Third method I was thinking of. I'm going to open this actually before I open it, I'm going to copy ghost to ghost-mod, and now I'm going to open it in a hex editor. You could do this in Vim, or I'm going to use bless in this case. Ghost mod. And let's make this big, and let's do a control F. We're going to search for that %s, and that's going to be in text. We'll do find next. And so here we are right down here, %s, and right in this middle of this string that's in the binary. So here's the 0D. 0D is \r. We're going to change this to 0A. Very simple. We just changed it from start the line over to go to the next line. And that's all we've done. So let's save this. And we will exit out. And now if we run ghost mod, when it gets to the part where it would have gone back and started printing over, it just prints the new line, and now we get the flag. So method number 3. Method number 4, probably the simplest of all. If you remember the previous video, I showed how we could solve both the first 2 challenges by tracing, with strace and ltrace. So let's try that here. We'll try strace on ghost, and we can see where it prints out here, but we don't really have any system calls involved in that. So not too successful. We'll do an ltrace on ghost, and we can see right here the printf call is a library call, and here's the first string, and then here's the second argument being passed in. In fact, the third argument, again, we don't think that's actually an argument, but we're just kind of, it's printing them. The problem is that the flag gets truncated here, and we can't actually recover it because it's thinking that's too small. or it's giving us too little space for the flag. We can do a -s and then give it a number like 1,000. Like how many characters do you want each argument to take up? And now it prints really long. This is a weird bug, and I'm not sure exactly what's going on here. But it's not printing here. And the reason it's not, it looks like it's overflowing off my screen, and like the line just keeps going. It's not line wrapping. This happens to me sometimes, and I can't explain why. If you pipe it into less, you can get the results here. So you can see now it is not wrapped. Now it wraps here. There's the full string. Here's the full flag. So we got the flag. We could also try just opening another terminal and doing ltrace -s 1,000. And again, 1,000 is kind of arbitrary here. I'm just trying to say, make it really big, make sure I get the whole thing. And it didn't work here either. But again, we can pipe that into less, and it will work just fine. So there's our result. So solve this challenge 4 ways. I bet you there's other ways to solve it. I would love, leave a comment if you found another way to solve it. But until then yeah, not sure what I'm trying to say there. Leave a comment if you figured out another way, and I will talk to you next time.